Hello, this is a demonstration videos of TuanDat intelligent system projects. So I do project B of OCR training, an OCR system that recognize math equation. So I have two state. I can draw, or I can draw or can upload an image. First, let's try draw. It's more intuitive. Let's do one. So the model accurately predicts the answer. One, let's do two. Let's how about three? Now let's do a bigger number. About 456. My 456. Okay, it correctly predict the results. How about something more difficult? How about 2x minus 1? Okay, 2x minus 1. It correctly predicted. How about I want it to be to calculate it? How about 25 minus about 16? Okay, 25 minus 16 and result is 9. How about uploading an image? Let's do this image. 2x minus 3 equals minus 7. How about compute? Okay, it correctly predicted. So how did I do it? So I trained the entire model in Kiko. It took me about 2 weeks to train the entire thing and iterating between them. So I had 3 different scripts of training. So the first one was pre-training. So initially it was an 100 epochs training script where I trained it with a bunch of around 400,000 non-label data. So the thing is that I want to experiment with self-supervised learning, where you don't have data, you don't have label, you don't have data label, and what I'm using is mass autoencoder. So what happened is I will mask 75% of the image, and I will feed the leftover 25% of the image to the encoder, and the encoder will take that and the decoder will use the 25% and reconstruct the image. That's the essence of self-supervised learning is. So we have 75% of mask ratio and about 8 by 8 patches of a mask. So I use vision transformer with 12 layers vision transformer with embedding of a 384 dimension, and I also have a lightweight 4-layer decoder that reconstructs the image. So after training, I realized, and testing it, I realized it wasn't good enough, so I decided to fine-tune it, and I call it fine-tune classification. So basically, just the fine-tune classification and segmentation are 2 parts of the process. The classification was the one I enhanced the ability to identify individual images, and after the model had been exported out after training using the fine-tune classification script, I realized it wasn't good enough, and I created the fine-tune segmentation. Because the classification only able to predict one individual letter, and it does it pretty well, but I want it to be able to predict a range of a math equation essentially. So what happened is in both stages, the encoder will get 30% of the head's learning rate. So this is a pretty standard procedure where the pre-trained feature should shift slowly while the new task specific head adapt quickly. On top of that, I also have like cosine one-up learning rate. So initially it will be big and a big learning rate, and naturally it will slow down as the loss coming closer to the bottom. And next is for training robustness, I apply quite a bit of augmentation, data augmentation, and balance sampling. So because I trained 85 different classes, and not all of them are very or have a well distributed amount of data. So what to encounter this? So a custom batch sampler guarantee that 2 samples per class per patch. So two samples per class per patch are given each time regardless of class frequency. So next is the mix-up. The mix-up will blend 2 training images and interpolate their labels. There's no label, but the model must output a soft distribution, not a hard class, which regularizes overconfidence. And the next is for inference engine. So everything is the inference is in this app. So at inference we receive a full how to say this. So it receives a full expression, a full image, not a pre-cop symbol. Rather than running a second neural network for detection. So I use a classical computer vision technique called ATSU. ATSU will binarize the ink, so the edges are extracted. The dilation kernel size is derived from the median field. Yeah, that's about it.